This is the power cord for the machine, 220 volts AC. This power cord, this is the machine signal cable. 3 signal lines. Where are these 3 signal wires connected to? This is a buzzer. 3 signal wires are connected to the screw feeder here. Connect to this location. The signal cable is connected to this location, and the machine remains connected when it leaves the factory and will not be separated. There are 3 groups of signal lines in this signal line, and the 3 groups of signal lines are connected to the machine respectively. This is a 3-core signal cable. Plug it in according to the direction, and we check the signal wires of the 2 cores. It is also inserted in a fixed direction. This is a 4-core signal cable. After we insert it, we must rotate the fixing screw to fix the signal cable, prevent loosening. This is the screw feeder module. This is the trachea of the feeder. This is the trachea. 2 tracheas above and below. This trachea is connected here. The trachea is connected to this location. There are 2 output tracheas, one is connected to the machine and the other is connected to the screw feeder. This trachea will open to more trachea. 2 tracheas are connected to the screw feeder. The screw feeder is connected to this side. Here the trachea is connected to the inside of the machine. This machine also needs to use air pressure. The trachea is the air pressure input. This air pipe feeds air pressure into this machine from the outside. The air pressure is connected to this machine. This is our air compressor, and the air pressure used by this screwdriver is output from this machine. This compressor generates air pressure and then outputs it to an automatic screwing machine for use. The air pressure output by the compressor enters this machine. After the air pressure enters the machine, one side feeds the screw feeder and the other side uses it for the machine. This is the air pressure switch. This is the controller of the screw feeder, which controls the delivery of the screws by debugging the voltage and frequency. The controller will be debugged before the machine leaves the factory, so do not debug the voltage or frequency. Keep the default parameters of the machine before leaving the factory. This display screen will be disassembled when shipped. We check how the signal cable and power cord are connected. 1 power cord, 1 video signal cable. Connect these 2 wires and you can use it. There are also 2 white tracheas, one is for conveying screws, and the other is for blowing air. The screws are fed from this white tube into the working head of the machine. You see, there's a screw in the white trachea. This screw will keep moving in the working head. And then this white windpipe needs to go through this sensor. This sensor needs to detect whether a screw has passed through. The trachea goes in here. Each screw needs to be tested by a sensor. And then finally this white trachea is inserted into the working head. When we add screws to the vibrating feeder, we need to pay attention to a few things. Don't add too many screws. Don't exceed the height of this white screw. Not too much. The number of screws is like this. We pour the screws into the vibrating feeder before assembling the product. Once all the machine's power cables, signal cables, air lines, and other connections have been completed, we turn on the power switch. The control handle of this machine. This is the operation handling. The handle is connected to this position. We turned on the main power of the machine. This is the switch of the screw feeder. Click and the vibrating feeder will deliver a screw to the workhead. This screw feeder switch can only be used when the machine stops running, and it is prohibited to use it during automatic operation. This is the emergency switch. This is to test the servo motor rotary switch. This is the cylinder up and down switch. This is the reset switch. You need to press it after the machine is turned on. This is a screw fasten cylinder switch. In the process of assembling the screw, an alarm occurs, and a screw needs to be added to the original screw position. We press this motor to test the switch. This is the reset button. An alarm occurs after the machine is turned on, so we press this reset button. This is the stop button. If an exception occurs, you press the stop button. This is the start button. Press once to start, and press twice to pause. This switch is responsible for blowing the screws. Press the switch, and the screws will be sent to the working head. This is the switch for the screw feeder. Press the switch and the screw will be fed into the working head. The screw will be delivered here. We need to press it to take the screw out. We need to press the left and right sides, and the screws will fall off. Press both sides of the working head and the screw will fall out. This is the cylinder up and down switch. I press the switch button and the working head moves up and down. When the switch is pressed, this motor moves up and down. This is the switch of the cylinder and the motor and other components connected to this cylinder. If there are screws in the working head, there will be a stuck problem during movement. Let's press this cylinder switch to check. During normal machine operation, it is strictly prohibited to press the screw feeding switch or the cylinder up or down switch. Machine running. Do not press this cylinder up and down switch and screw feeder switch. If you press this screw feeder switch, we must remove the screw from the working head. Pressing the positions on both sides, we're going to take this screw out. This is the emergency switch. Press the emergency switch in case of emergency. This is a motor test. Press the motor test manually, and the motor starts to rotate. Pressing this switch means rotating. This is the cylinder moving up and down. This is the reset key. Press the reset button after booting. Press the reset button and the working head will move to the origin position. This is stop. This is the machine start and run button. Click to start. Press twice to pause. Press twice to pause. Click to start. Press twice to pause. This is a 100W servo motor. This is a ring sensor. There's a green light, but when the screw passes through the sensor, it turns red and flashes. If the red light doesn't flash, you need to adjust this sensitivity. This is the cylinder of the locking screw, and this is the stroke position of the debugging movement. This is a blowing trachea. Under normal circumstances, this trachea is generally not used. This is the screw delivery pipe, and this is a CCD camera. You need to use a camera to make the program. Then this is the nozzle of the working head. There are screws in the nozzle of the working head, so you need to press the two sides to take out the screws. When we make the program, we need to use the camera to observe the location of the screw hole. Observe the coordinate position of the screw hole through this screen. This is a batch of rods. This is the working head nozzle. These are wearing parts. It has been used for a long time. If it keeps slipping or rotates empty, it needs to be replaced. Loosen this screw to take it out. If this buckle goes to the top, the batch rod can be taken out. This is the cylinder for clamping the metallurgical tool. This is also a compression cylinder. This is the working head part of the removal screw. If the screw needs to be removed, this part needs to be replaced. If you need to remove the screws, you need to use this part, and we need to remove the nozzle of this working head. This is the part that removes the screw. We loosen the screw here and we can replace this part. You can take it out. After loosening this screw, it can be pulled out downward. The components of the machine are introduced today.